Here's our first example of solving an equation using variation of parameters. So as we did with undetermined coefficients, we'll start by finding the homogeneous solution. And then again, just a reminder that the final answer is going to be the homogeneous plus the particular solution. So the homogeneous solution, again, we're going to set up the characteristic equation. For this one, we have r squared plus 1 equals 0, which means however you want to solve this using factoring or the quadratic formula, you can also just move this 1 over to the other side and then recognize that r is going to be plus or minus the square root of -1. So r is going to be plus or minus I, which means that we have our complex solutions. So the homogeneous solution is going to look like C1 times e to the 0t cosine of 1t plus C2 e to the 0t sine of 1t. Again, noting because there's a 0 in the place of alpha with our complex solution. So at this point, we've got y1 and y2 picked out, and we can use those for the second step, which is to find v1 prime and v2 prime. Again, the form here is that the particular solution is v1 y1 plus v2 y2. Now, without going through and resolving everything, we can simply take advantage of the formulas we just wrote down right here. So we're going to calculate the Wronskian first, where that's the determinant of this matrix y1, y2, y1 prime, y2 prime. So here we have y1, y2, y1 prime, y2 prime. And again, remember for the Wronskian, we take the product of these two and the product of these two, and we subtract in that order. So we have cosine squared minus a negative sine squared, so plus sine squared. Notice the change in signs here. If you mess up one of these signs, it'll turn out that your work will be much, much harder later, or maybe impossible with that mistake. So be very careful with the SIGN sign of this Wronskian when you subtract. So once we have W, V1 prime is going to be, remember that's negative F y2 rather, over AW. So F in our case is secant. So it's going to be negative secant of t. Y2 is sine of t. All over A in our case is 1 times cosine squared plus sine squared. Now hopefully at this point you've already noticed that this denominator, or the value of W, according to the Pythagorean identity, is just equal to 1, which is going to make life a lot easier when it comes to finishing the process. So v1 prime is just negative secant of t times sine of t. We can do the same with v2 prime. That would be f times y1 over aw. Again, the aw is again going to be 1, just like in the last example. So once we figured it out for v1 prime, we don't have to redo any work. And all we have is f, which is secant, times y1, which is cosine. So we have v1 prime and v2 prime. And the last step is just to integrate each of those to solve for v1 and v2. And this is the one step that, again, can be tricky because we need to be able to integrate these two things. So we need to brush up on our integration skills as needed. So step 3, the last step, is to integrate to find v1 and v2. And again, this is the part where it might be kind of tricky. But let's take, for example, to find v1. So v1 is going to be the integral of negative secant times sine. To do this, It doesn't look like something we can directly integrate, but with a little bit of use of some trig identities, some very simple ones, just remembering that secant is 1 over cosine, we can rewrite this as negative sine of t over cosine of t. And at this point, hopefully this looks like something you've done before when you were learning u substitution. It's a very simple u sub problem where we simply let u be cosine of t, du is negative sine of t dt, and conveniently enough we even have the negative sign built in here. So this would turn into the integral of 1 over u du, or ln of u plus c. Now, we could worry about this plus c, but we're always going to assume this equals 0. And the reason for this, the reason we can be kind of dismissive of that, is that we're looking for a particular solution. Remember, the whole theory backing all the way back up to when we started learning undetermined coefficients is that if we know the homogeneous solution and we can find a particular solution that fits the non-homogeneous case, then we're done. We don't need to find any or all non-homogeneous solutions. We simply need one. And so we'll pick ones that don't have any unnecessary additional details like the plus c. So we'll assume that equals 0. So v1 equals the natural log of the absolute value of cosine of t. And then v2 is even easier, because when we integrate secant times cosine, again, since secant is 1 over cosine, secant times cosine just reduces down to 1. And so when we integrate that, we just get t. Again, it would be t plus c, but we'll assume, again, that it's t. Which means we're pretty much done. We know what v1 and v2 are. So our particular solution is v1 times y1, where y1, which do we call y1? We called cosine y1. And then plus v2 times y2. So there's our particular solution, which means that our full solution, the homogeneous plus the particular, so that's the c1 cosine t plus c2 sine of t plus etc. So there's a full solution, the combination of the homogeneous and the non-homogeneous cases. So again, there's a lot of detail here, but basically it boils down to solve the homogeneous case, then use the formulas for v1 prime and v2 prime that were given back here that you'll find on your formula sheet. Use those. Once you've calculated v1 prime, v2 prime, it turns into an integration problem. So it's more like a calc 2 kind of question at that point. So there's a few steps, but the process follows from there. And really this third step is the only one where you'll find yourself having difficulty in different problems most likely, because that's the part that can be the trickiest.